How much math do you need to do all of that?
You need quite a bit of math. There's a lot of calculations, especially when it comes to automating a piece of scenery. You have to figure out how much it weighs. So it's taking all of the different materials that you've built into the piece of scenery, figuring out the weight, to then figure out the size of a motor that you need to pull it on stage or off stage.
Wow, that sounds like a lot of math.
Do you need a lot to know where to place the objects as well?
You need to have pretty good, geometry and a little trigonometry, and you're doing a lot of triangulation. You're doing, your 3, 4, 5 triangles to figure out how you're getting things squared out. Measurements. You have to be able to, add together a bunch of measurements. Something that's 3'6" this way and 4'6" that way on the stage. So it's a lot of figuring based on measurements.
Well, thank you very much. That was great.
You're welcome.
Thank you.
Like he said, this part involves some basic math. There are 2 very important lines in the theater. One is the plaster line, which runs along the front of the stage. The other is the center line that runs, well, through the center of the stage. With those lines in place, they can set up a grid. Now it looks like a piece of graph paper. If something needs to be set up on the grid somewhere, you just need to know its coordinates compared to those 2 lines, and you'll find it. Every line over the grid can be written in an equation, and using simple math, the stage engineers and construction crew can not only put things in their place, but move them around without bumping into anything. To make this easier to visualize, they use a model, which is a scale reproduction of the complete stage. Scale means that all of the distances and dimensions have been reduced by the same amount. On this model, every foot on the stage has been reduced to a 1/4 inch. Someone with good math skills, mostly algebra, can make a scale model of this or any stage. And that's the set designer's job. Engineers use this model to make the set designer's vision a reality.
Wow, this is really amazing.
Even for math?
Even for math. My teacher was right. I guess I am going to need this stuff. And I guess just being here makes it so real.
Yeah, it's going to take a lot of math, not only to put these things in the right place, but to move them around.
What do you mean?
Set changes. You just have to move.
Really?
Yeah. You want to see how?
Yeah.
You know what a pulley is?
I think so. Isn't that one of those things where a rope runs through a circle and makes it easier to lift things?
It's something like that. Basically, it's a tool that gives the user a mechanical advantage, so it's easier to do work.
Wow. Do you have to plug it in?
No, it's not electronic, at least not in this case. You see, in the theater, they'll use these pulley systems to move things like lights and scenery.
Wow, I can't believe they use something so simple to move something so heavy.
Yeah, well, maybe we can ask someone about it. Hey, Scott.
Hi there.
Hi.
Just admiring your pulley system here.
Okay.
And can you tell us how this works?
Sure. Well, basically, it's actually very, very simple in that the same amount of weight that's on the line set, which is out over the stage, is put on the arbor, which is right here on the line set.
Okay.
And basically what happens is we'll bring the pipe in, the batten, or the line set, any one of those 3 names, into the ground or down to the stage level so you can reach it.
Okay.
And then somebody will go up to the grid, which is at the very height, or for this theater, it's at 76 feet from the stage floor.
Oh, that's above us.
Yep.
Okay.
And they'll load on the equal amount of weight to what's being applied to the line set out over the stage.
So if you have equal weights on both sides, it shouldn't take too much to get it in motion, right?
Nope. Single person,
Skinny
can
guy
move
like
it.
me?
Skinny guy like you can even move it. No
Really?
problem. Yep.
I can move nearly 2,000 pounds.
Easily.
Wow. That's pretty impressive. So you have these things move up and down.
Yep.
And it's just through this system here. And is this done manually?
This is all done manually. Most of the time it's done manually. There are times that we do put it on motors.
Okay.
And that's typically when it gets above 2,000 or 3,000 pounds.
2,000 or 3,000 pounds. Yep. Okay. Well, I'm at my limit at 2,000 pounds.
2,000 pounds will be your max.
Okay. So if that's we're moving up and down, do you also move things left and right across the stage?
Yes, we do move things left and right across the stage.
Okay. How do you do that?
We typically do that with winches, with motors. That'll run it back and forth. We do that with motors only because most of the time we're moving heavier things or larger objects.
So how long does that take, this motion back and forth for this piece?
For this piece in the show, this one probably takes about 20-25 seconds to move on stage and off stage. But that's at a pretty stately pace. It's not moving too fast and it's not moving too slow.
Okay.
We can move it faster, but then it looks a little odd.
All right.
Wow, simple machines are really cool.
Yeah, simple machine. It is a simple machine. It just takes so little work.
Yes.
Either pushing a button on a motor or just a single person doing this. During a stage show, how many people are back here working on this?
For this production, there are 8 people working this stuff backstage.
Yeah?
Yep.
8 folks running all these lines.
Yes.
How many of these lines are in use?
Off the top of my head, I think there's about a dozen that are all in use during the show.
Okay.
And then there's 3 of these larger units that move on stage and off stage by motor.
Mm-hmm.
But the other thing we also have in the show is we do have actors flying.
You have actors flying.
Yes, that are in the air.
That's pretty cool.
Yeah.
Is
So
that
the-
another, is a person handle that with a pulley?
There's actually a motor that moves them up and down, but there's a person with a pulley moving them stage right and stage left.
Really?
Yes.
Oh, that's pretty cool.
Yeah.
Well, thanks a lot for showing us your pulley system.
Oh, you're
That was
very welcome.
fantastic.
Yeah,
Very
thanks,
welcome.
Scott.
You're welcome.
Really cool.
So what do you think?
I think I should listen to my teachers when they say I need math and science.
You know, you may not know it now, but you're going to use everything you ever learned one way or another.
Thanks. I'll keep that in mind.
Good. Well, my work here is done. Enjoy the rest of your class. I don't think you have much left.
Okay. Thank you.
Bye.
Bye. Am I awake? What day is it anyway?
Why, it's Christmas.
Really?
No.
Oh. Well, I guess it's still a good day to learn science.
You okay?
God bless us, huh? Everyone, your reports are due on Monday, so thanks a lot for coming, and I'll see you then. I'll collect them then. Go on, get out of here. Have a good weekend.
All right, let's go and get started on this project.
What's up with you?
I had the weirdest dream. Thank you, Professor.
Oh, you're welcome.
Support for City Science has been provided in part by Science Chicago, the world's largest science celebration, awakening the inner scientist in each of us through thousands of dynamic interactive activities. For information, go to sciencechicago.com.